Hello everyone, how are you all doing? I hope you're doing great. मैं हिंदी में नहीं बोलूंगा. I won't speak in Hindi because many people were suggesting in the previous comments to sir, please don't use Hindi. I'm from South India, something something. So I'll be speaking in English only. I hope that is fine. I'm so sorry about that. Now we have roughly 10 months left for ISI, right? Roughly less than a year, obviously. Next year in the month of May, first week or second week of May, you will have the exam. So not even 10 months, man, less than that, I think. So you better be prepping up your basics, your theory part, So I'll be doing my part. I'll be trying to helping you out through this, right? If you need theory of something, let me know in the comments which topics at because number theory will be pretty much over after this session. All right, if you want me to cover a theory part, then definitely I will do that for you. Okay, so let me know in the comments what you want, what you are expecting from me uh, in terms of theory or whatever. And till then, I'll be solving questions for you. I'll be bringing interesting questions which I find somewhere or the other for you guys for practice. Now, this is the first question. What are the solutions of x in the Diophantine equation x cubed plus 5 is equal to 117 y cubed? What are the solutions? So the solution, the hint is given in the options itself. It could be multiple correct. Pause the video and try it out. Let me know in the comments what is your response. All right. Now, I would, okay, I hope you have paused and tried. The answer is no solution. You don't have any solution. Why don't you have any solution? What can you say about this number 117? It is 1 plus 1 plus 7, which is 9. So it is divisible by 9, and you can check very easily that it is 9 into 13. So mod 9, mod 13 will be helping. These two options seem plausible, right? And when you are solving differential equations of this type, where you have x cube and y cube separately, you use modular arithmetic in a way such that if you mod it with something, one of the variables should disappear. Since we don't have any coefficient for x cube, we will use mod 9 or mod 13 only, right? So first let's use mod 9. That means this will be 0. So x cube plus 5 is congruent to 0 mod 9. Now, is this possible? Is x cube congruent to minus 5, which is congruent to 4 mod 9? Is this possible? So now that is a very easy thing to check. What are the model? So x is congruent to either 1, 2, okay, 0, 1, 2, 3, 4, minus 4, minus 5. Okay, minus 4. I'm so sorry. Minus 4, minus 3, minus 2, minus 1. So yeah, that will be mod 9, right? That will be the easy part. Now x cube is congruent to 0, 1, 8, 27, 4 cube 64, minus 64, minus 27, minus 8, minus 1. Mod 9. Now these are congruent to 0, 1, minus 1. 27 will be 0, obviously. 64 would be mod 9, right? 64 would be 1, and this would be minus 1. This would be 1. This would be 0, sorry. This would be 1, this would be minus 1. So overall, mod 9, any cube would be 0, 1, minus 1, mod 9. No other options available. That means any number cube can never be. So I'll write it down here. So therefore, x cube congruent to 4 mod 9 is not possible at all, right? And that obviously means that there are no solutions. Is that clear? I hope it's clear. It's a very easy question. Okay. Okay. How many non-zero integer solutions does this system of equation have? So I want you to pause the video and try it for yourself. It's actually a very, very interesting question. Lovely. So I hope you have paused. I hope you have paused. Okay. So what is the thing? There is an identity which we want to use. What is it? If I have x plus y plus z whole cube minus x cube plus y cube plus z cube, will it have this expression? If you put x plus y equal to 0, implies this expression, let's say this expression is e, implies e is equal to 0. That implies x plus y is a factor of e. E for expression. I just used it. Similarly, y plus z is also a factor. Z plus x are also factors of e. Don't you think? If you put x plus y equal to 0, do you see that this is going to be 0? This is kind of obvious. So what can we say? Therefore, x plus y plus z whole cube minus x cube plus y cube plus z cube is equal to x plus y plus z, and z plus x, right? So you see, and there will be a constant a. How do we find a? We will see. But first of all, you must understand that this is an identity. And what does an identity mean? True for all. Okay, maybe I'll use for all values of x, y, z belongs to R. Okay, this is true because this is a degree 3. Degree is 3. Here also the degree is 3, right? So it is kind of obvious that you will have this. How do we find a? How to find a? It is also easy. Finding a meaning you put some value, right? Maybe you'll put um, hmm, you put x equal to 0, y equal to 1, z equal to 2, something like that. That should help. So you'll have 1 plus 2, 3 cube minus 0 plus 1 plus 8. 0 plus 1 plus 8. Huh? That is equal to a into 0 plus 1, 1 plus 2, 2 plus 0. So this is 27 minus 9 is equal to a into 1 into 3 into 2. So this is 18 is equal to a into 6. A is equal to 3. So a is 3. Since that is true for all x, y, z, a will be 3. You can try with any other values of x, y, z, and I'm pretty sure you'll always get a is 3. So therefore, the identity is x plus y plus z whole cube minus x cube plus y cube plus z cube is equal to 3 into x plus y plus z, z plus x. Right? Now, okay, what do we have exactly? We have that x plus y plus z is equal to 3 and x cube plus y cube plus z cube. Why did I use this? Because I have these two expressions. I have to use these two expressions. So basically, I have 3 cube minus 3. 3 cube minus 3 is equal to 3 into what is x plus y? I can write that as 3 minus z, and this I can write it as 3 minus x, 3 minus y. Correct? We definitely have this. So this is what 27 minus 3. So 24 is equal to 3 into 3 minus x, 3 minus y, 3 minus z. So what do we have? We have 3 minus x 3 minus y into 3 minus z is equal to, I think this will be 3 into 8, right? So what can we say? 8 can be 2, 2, 2, or 8 can be 1, 2, 4. Can it be anything else? 118, that is also possible. And there will be three iterations of this, right? Three iterations of this. Um, this will give me x equal to y equal to z equal to 1. Not a problem. This will give me the solution. I'm looking in terms of the triplets x, y, z. So I'll write it like that. So this will be 1, comma 1, comma 1. Okay. This will give me 2, comma, uh, uh, so wait a minute. So this will give me 2, comma 1, comma minus 1, right? And there will be iterations of this, so it will have 6 iterations. But this will give me 2, comma 2, comma minus 5, or rather, yeah, something like this. There can be many more other solutions, right? But what are we asked exactly? How many non-zero integer solutions? Yeah. So non-zero, we are doing it. It's not a problem. Hmm. Okay, so we are done. No issue. We don't have to find positive solutions or anything strictly, so we can do this. 2 comma 2 comma that, or we can also write it like x minus 3 into y minus 3 into 3 minus z, you know. And if I do this is 1, this is 1, this is 8, something like that, then I'll have 4 comma 4 comma minus 5. That is also possible. This is possible, this is possible. So which one do we take really? If x y are 2 2, still it is working, 4 4, still it is working. So we'll have a lot of solutions, don't we? Oh, we will have a lot of solutions. But uh, hmm, if I take 1, 2, 4, again I'll have different solution. So obviously there will be more than 1, 4, or 7. The answer should be none of these. Got it? There are numerous solutions, and yeah, this is how you solve it. That's the thing. So I hope this was clear. Got it? Next question right now. Again, pause the video, try the solution. This is a subjective type. We don't have options. So pause the video and try to solve it. Okay, I hope you have tried to get it solved. So, see, I think pretty much always we will look for some kind of parameterization, right? So, one thing is if we can factorize, we will try to factorize, but that's not going to work. All we have to show is we have to show there are infinitely many solutions. That means if you are able to show that x, y, z can be written in terms of some parameter, right? Some parameter t or n. If it can be written in terms of n, then definitely like we like th for any value of n you have a solution, so you will have infinitely many solutions. If you think we can write it like x, y, z can be written in terms of n power k or something, it's not going to happen. Okay, because we have to add two things, and when you add two things, if y is equal to n power b, z is equal to n power c, then y power 3 plus z power 5 is equal to n power 3b plus n power 5c, and something will be taken common. So my idea was that when I solve this, I mean, you can take n power 5c common or something, and you will have n power 3b minus 5c plus 1. So this term will be there. So x square must have something like this, right? So that means what if we already take n to be x to be some n power a into n plus 1 power b, right? And then y has to be like n power c into n plus 1 power d. And z has to be something like n power p times n plus 1 power q. So that will imply that x square, which will be n power 2a n plus 1 power 2b, y cubed n power 3c n plus 1 power 3d, z power 5 n power 5p n plus 1 power 5q. Now, what I want to happen, what I want to happen is that n power 2a into n plus 1 n plus 1 power 2b is equal to, I want these two to be added up in such a way, n plus 1 power 3d plus n power 5p n plus 1 power 5q. Now I want to take something common, n power something, n plus 1 power something, such that here we'll be left with n plus 1. You know, we should be left with only n and 1. So one of these should give you n, and another one should give you n, should give you 1. So basically, I'm taking whole of this common, and only n is being left here. So is that possible? That's the idea which I wish to chase. And the moment you do that, you see um, that this should match the powers here. So what can I do? What if 2a is equal to 3c? That means the least you can take is a equal to 2, c equal to 3. So we'll have 6. But then I have to match it with 5p also, or 5p plus 1. How about that? So how about p equal to 1? That works? No, that should work. Okay. And then I want 2b is equal to 3d is equal to 5q. Is that possible? Oh, no, no, it's not 5q. If I'm taking n is common from this one, then 1 should be common from this one. And 2b should be 3d equal to 5q, okay, plus 1, plus 1. Yeah, that should be the case. 3d plus 1 and 5q plus 1, because you are multiplying another n plus 1, and then it is equal to 2b. I hope you're following my argument, right? So what kind of numbers would suffice here? So first of all, 3d is equal to 5q. That means d is equal to 5, q is equal to 3. So this is 15. So 2b is equal to 15 plus 1, 16. B is equal to 8. So that is fine. Wow, interesting. So will this work? If I take x to be n square n plus 1 whole power 8, y to be, y is having c and d, right? N cube and n plus 1 power 5, n cube n plus 1 power 5. Is that making sense? Okay. Oh, C is 3. Yeah. Okay. And Z is N. So P is 1. So N into N plus 1 whole cube. So what is X square? n power 4. Dude, that's not working, man. 2a is 6, na? So a is 3, c is 2. Oh, I got it all wrong. A is 3, c is 2. So this is n power 6 into n plus 1 power 16. Y cube will be n power 6 into n plus 1 power 15. Z power 5 is n power 5. Ah, okay. Oh, I did something wrong. I did something wrong. This should be equal to 6. In that case, why did I take plus 1 here? This plus 1 should be 5p. Ah, okay, okay, okay. So some multiple of 6 plus 1 should be 5p. Ah, I got it so wrong. I got it so wrong. So all these are fine. 2b and all that is fine. So only the first part has to be corrected. Okay, so we are solving it together. That's fine. So 2a equal to 3b, or 2a plus 1, 3c plus 1 is equal to 5p, right? So that if we are taking 5p common, so in that case, this should be multiple of 6. So 6k plus 1 is equal to 5p. I can take k equal to 4, right? So 5p is equal to 25, p is equal to 5. That works. That's nice. So in that case, I'm going to take a is equal to, I want this to be 24. So a is equal to 12 and c is equal to, I want that to be 24. So 8. A is equal to 12, c is equal to 8. A is equal to 12, c is equal to 8. Okay. 12 square 24, 8 cube 24. P is uh, P is 5. So P is 5 already. So this is 25, n plus 1 whole power 15. So now what do we have? What is y cube plus z power 5? That will be n power 24 n plus 1 power 15 plus n power 25 into n plus 1 power 15. I can take n power 24 times n plus 1 power 15 common, and I'll have n here and I'll have 1 here. So this will be n power 24 into n plus 1 power 16, and that will be, okay, and that will be n power 12 into n plus 1 power 8 whole square, which is x square. So since we have a generalized solution, so this is a solution. So this is a parametric solution. Parametric. Okay. Yeah. The moment we have a parametric solutions, we have solutions for all x. Since we have parametric solution, we have infinitely many solutions. Implies infinitely many solutions. Okay. So yeah, that's it. That's about this question. Find all the positive integer solutions to the equation x square plus y square is equal to 10. Do the same for x square plus y square is equal to 47. So this is actually very easy. What is the greatest square which is near this, right? That means x square is between 1 and 10. That means x is between 1 and 3, I think. So x can be 1. If x is 1, then y square equal to 9. That implies y is 3. We're only interested in positive. So if x is 2, y square is equal to 6, no integer solution. But if x is 3 again, y will be equal to 1. These two are solutions, integer solutions. That is fine. This question is actually very easy. I don't know why I put this here, but anyway, you can look for x square plus y square is equal to 47. How do you solve this? What is the greatest value x square can have? X square is less than or equal to 47, greater than or equal to 1. That means x is less than or equal to what is the greatest square? I think 36. So it is 6 and 1. So you keep taking cases. X equal to 1. So y square is equal to 48. No solution. X equal to 2. So it is 4. So y square is equal to 43. No solution. X equal to 3. So like this, you keep on going. X equal to 4. X equal to 5. X equal to 6. That's it. So here y square equal to, you're subtracting 9. So that will be 38. No solution. You're subtracting 16. So that will be 31. No solution. Subtracting 25. That will be 22. No solution. Subtracting 36. If you subtract 36, it will again be 11. No solution. So overall, there is no solution. Okay. So it doesn't have any solutions. Okay, fine. Find every Pythagorean triangle with this following property, that the sum of the length of sides, which is the perimeter, is equal to the twice of its area. Let's say the Pythagorean triangle has x, y, and z like this. One immediate thing which we have is x square plus y square is equal to z square. Pythagorean triangle means a right angle triangle, which follows a Pythagoras theorem. All right. And whose perimeter is equal to the side. And x plus y plus z is equal to twice of half xy, half into base into height. So that means we have x plus y plus z is equal to xy. That means I can write z is equal to xy minus x minus y. Interesting. So I will have x square plus, so let me put this value of z into this. So I'll basically have x square plus y square is equal to xy minus x minus y whole square. That will be x square y square plus x square plus y square plus xy minus x into this, x square y minus xy square. Okay. So x square plus y square will be equal to x square y square plus x square plus y square plus xy minus x square y minus xy square. So obviously these two will get cancelled. We're left with this, this, and this. I think in the whole of that, you can take xy common and you can get xy plus 1. Here you see this is minus xy into x plus y, right? Plus x plus y equal to 0, right? I don't think, oh, there is a minus x minus y. This is equal to 0. Xy is definitely non-zero, right? So you have xy minus x minus y plus 1 equal to 0. Very easily, you can solve it as x minus 1 into y minus 1 equal to 0. That implies x equal to 1, y equal to 1. Right? Whose perimeter is equal to, yeah. So that's pretty much it. But that gives you z is equal to root 2. So is that a valid solution? I'm not sure, because we're simply solving the equation. I don't think it was said to be integer. When we say Pythagorean triangle, do we mean integer sides? I'm not sure. So let me know in the comments if you actually understood everything or not. Um, so yeah, that's all for today. So guys, a quick announcement. If you're interested in this video, most probably you're interested in higher mathematics, mathematics which is beyond the school syllabus, beyond even the JEE syllabus, right? So if you are such a person who enjoys higher level mathematics, we're bringing a course for you named Target Math. We know that there is full math mastery, but that covers the mathematics in general. But this batch will cover mathematics in a higher level. All right, if you are interested in that, this batch is for you. It will be starting from 21st of July, so hurry up. It's going to start soon. It will be taken by the great Chetan sir. I hope you all know him. Definitely you must be knowing him. Now, who is this batch for? This batch is for class 12 students. It's for droppers. It's for ISI aspirants mainly, CMI aspirants also mainly. Or if you are simply aspiring for JEE and if you want a stronger mathematics, because JEE mathematics may not be that uh, stimulating for a lot of students unless you're doing calculus or something, but this batch will dig deeper into all the topics which are required for mathematics. If you enjoy mathematics, this batch is going to help you. Now, what are the highlights of this batch? There will be more than 95 live sessions, 3 sessions a day, 3 p.m. to 4:30 p.m. again taken by Chetan sir. UGA plus UGB pattern practice tests. So because ISI and CMI require higher level mathematics, and their pattern is in general, that's how they test, and that's why it is so good. You are going to be practicing in their pattern. Assignments every day after the session, Telegram group for discussions after the class, monthly progress report. This as constant in every batch. Now, a free bonus of ISA UGB mastery batch, right? If you're preparing for this, you'll also require preparation for UGB. If you know what UGB is, it is a subjective paper, 8 questions, 2 hours. So that mastery, writing a subjective solution is going to take some practice, and this batch is going to teach you that worth 1,000 rupees you're going to get for free if you take this batch before 21st July. Now, if you want to avail this price, please use the coupon code given below and you can avail it only for 13,000 rupees. And remember, it is 95 plus sessions covering all of mathematics in depth. So, yes, this price is definitely worth it. So, please go check it out. Link will be in the description. Please uh, go check it out. That's it. Take care. Tata. Don't forget the coupon code. Continue with the video.